there's one missing, right. That's it from us. We'd very much like you to use it. We'd very much like you to give us feedback and eat more chunky bacon. Please visit our website. Ask us, write us emails. We'll be around at the end of the talk, and we'll read the emails going to that address also in these days. So just contact us. Thank you very much.
Okay, next one is a lightning talk about clock tamer, and then after that, Sylvester will talk about chip tunes on microcontrollers. Is that okay? Sylvester, can you give me a sign? Okay, there you are. Good. So guys, finally we're getting in tune, we're getting in the mood. Sorry again, thanks for your patience, we love you.
Test. Yeah, it works.
There we go.
Yes. No PPT, but PDF here. This one, yes. Okay. Yeah. Okay. Hi, my name is Alexander Chemeris, and I'm here to present you a clock tamer project. Let's start. As it was mentioned several times during the Congress, USRP is a great tool for software-defined radio, but it has one big problem. It has a fixed reference clock. It's 64 megahertz, and many wireless protocols require different clocks. Just to list the few. And so we created this open software and open hardware project for high accuracy clock source, which may be useful for wireless and ham radio projects, for some wired communications, DC and DC converters, and some ham measuring equipment maybe. And the projects who already may get benefits from this is OpenBTS and AirProbe, which already were mentioned several times during the conference. And it's a highly configurable clock source, which it may help you make your software-defined radio even more flexible than it was before. It may be controlled through the mini USB connector or through the SPI connection with a simple text-based control protocol, and you may tune it with up to 1 Hertz precision, but that's just a current firmware limitation, and with later firmwares it should be possible to get the finer precision. It's also a universal clock source. There are many hardware options available. The standard version uses just 1 output, but you can get up to 6 outputs. You can get locking to GPS. On the back side we have a place for GPS module. You can get the external reference signal input if you have a very precise clock. You may get it to here, and you can get the VCO output, direct VCO output. For internal reference sources we have a T6O plus fractional PLL, or we can get VCT6O plus DEC, which is useful for when you're using locking to GPS. Just some facts about the project. The current version, standard version of hardware is 0.28 ppm accuracy, stability, and with GPS you can achieve up to 50 ppb precision, and with the better math and firmware you can get below the 1 ppb stability. just we need to implement some more math magic in firmware. And the source code is already available and Google Code, and schematics will be published online sooner, I hope right after the Congress. We have 2 experimental boards for sale here. They look like this. And the final version of the hardware will be available in late February, and everyone who wants to buy it, just tell us. Oops. And we need some of your help if you're interested. There are, as usual, pretty much places which can be improved. And it's, as I mentioned, better math for GPS synchronization, more firmware features. We need some host library which can be used to simplify interaction with the hardware. I plan to write one myself, but if anyone wants to help, you're welcome. And we plan nice GNU Radio integration, because with this setup you can get you can talk through the SPI port to the clock tamer, and if you have a nice GNU Radio, then you don't need any external cables to control your clocking source. That would be nice. We already have some prototype, but we need some nice GUI blocks for doing this from GRC. And we need your use cases. How do you use this? When do you use this, and why do you use this? Just to make it better. Oops. And that's our contact information. You can find us in GSM room on the 2nd floor, or you can call me with this local extension if GSM network is up, because I am using the GSM phone. But the safest one is just get to GSM room. We are 90% time there. Thanks. That's all.
If you need it, then we use the presentation CD. So, yes, so it's good news, bad news. Again, the good news is we've managed to come up with the schedule. We put it online, including all the slides, and now we can't go online again. That's the bad news. So we try to do this all locally now. No. He removes this. It's going away. Wait.
To do it, I've got to play some chiptune later from the speaker. Have I just attached the microphone to the speaker?
Seht ihr das hier irgendwie? Also, Chiptune-Talk da. Chiptune. Gut. Und Teilnehmer? Also. Na, ihr hattet euch zugeschickt, sonst wäre es ja hier schon mit dabei. Vielleicht.
Ja, das habe ich in der letzten Minute zugeschickt.
Aha, gut, ja, dann bitte früher. Dann hilft. Okay, Dinner? Right. Warte bitte noch auf ein Foto.